Hello everyone. In this session, we are going to discuss about different data models in the DBMS. So, nearly the 4 to 5 different types of models in the DBMS. In the earlier model, how the evolution was arrived in the data models. That we are going to discuss under this. The data models are essentially for introducing the abstraction. So how the data are going to be specified, how it is each and everyone linked to one another. So for this, data model is essential. So different types of data models. Initially we followed hierarchical, then network model, entity and relational and object oriented model. Now hierarchical, it is a traditional model, and this model organizes the data in a tree structure. How the tree structure will look like: the root, and from then branches, then leaves, then next level. So the level by level the data are going to be expand. So this model to represent and then to understand it is a very easy in the real time to mapping the website. This is the example of the representation, how the clothes are represented. So initially the clothes that are going to be categorized into two types, men's and women's, and from the men's what are all the types they are going to be classified, further brands, and then price wise. Like that the tree structure is going to be extended based on the categories. In this model, they are having as a features one to many relationship, and we can have the parent and child relationship. We can have the pointers, but here the deletion is one of the problem. What are all the advantages of this model? It's the first thing is a very simplest and fast traversals we can able to do it because of the tree structure. And then any changes in the parent node is automatically reflected in the child node. The disadvantages, the complexity when the data size is going to be bigger, and then parent node is deleted, and then it is automatically the child node will be anonymous. So that is a very difficult thing to handle in this model. The next level, the networking model, it is a little bit extension of the hierarchical. So this model is recommended for the best before than the relationship model. And here the hierarchical, only the parent and then child relationship. So here the difference between these two models, the record can have the more than one parent. Here the before model, the hierarchical, only the child having the one parent. Here the child having the more than one parent. For this example, the college is further divided as a department and then library, but the student have the relationship between these two nodes, that is a department as well as a library. So any one parent is going to be deleted or something changes, so still we have a relationship. Here the features, many merge to more relationship as they more number of the path, and we can apply the circular linked list. Here the advantages is accessing the faster, and then we can have the parent and then child relationship. So the same thing, what are the changes we are doing in a parent, that will reflect in your child. The difficulty is a little bit complex because of we are having the more relations. Entity relationship model, it is called as a ER model. It's a very simplest model because it is a pictorial representation, so that it's very easy to understand and develop with the specifications. Mainly it contains three components: entities and then attributes, then between the relationship. What is meant by entity and then relationship diagram means, here the faculty, it's an entity that is represented as a rectangular. All the entities are represented by the rectangular. How the entity is going to be described, so that is called as the attributes. So the faculty is described by their ID, name, phone number, salary, date of birth. Similarly for the department, So for the department description is department ID, name and then location. All the attributes are located denoted by the oval shape. What is the relation between the faculty and then department? So that is represented by the diamond shape. So that is for indicating the relation. So faculties works for the department. So this is the ER model. The feature of this ER model is graphical representation, visualization for the good database design. So most widely we are using when we are just seeing the advantages, very simple, better communication, we can convert into the any other model easily. But the limitation of this model, it's not a industry standard, as well as some information it may be a hidden. Relational model. So this is the most widely used model even nowadays. It's a 2D representation, rows and then columns. It's a table. Each and every records are represented by the rows, and then a representation of the each and every records given in the column. If we are just taking the employee, each and every rows the employee's information available, the columns employee number, name, job, whatever the extensions or attributes, that is going to be represented in the column wise. So here features, records and then attributes. Advantages, it's a very simple, scalable, and it's a structured format. So when we are just going for the limitation, it's a hardware overhead. Other than that, remaining everything is a advantages for us when we are using as a relational model. Object oriented model, it's a real-time problems are easily represented through the object oriented. So here each and every thing is converted as an object, and then linkages is we can able to maintain how each and every objects are interlinked with other. So the complex data like images, audios and videos can able to store easily in this model. Objects are connected through the links with the common attributes. So here the faculty, department and then campus. So the faculty and then departments are connected through the common attribute as a department ID. So similarly department and then campus are going to be connected through the campus ID. So like that each and every objects are going to be connected. So these are all the evolutions of the data model. So we can see in the next session. Thank you.